Good evening, everybody. I'm supposed to sit. Okay. Right. So, good evening, everybody. Please switch off your phones or put them on silent or toss them out the window, whichever is most convenient for you. Yeah.
From the 10th floor.
Yes, that's right. Testing gravity. We're here to see that. Anyway, so thank you for coming. For those of you who are new to this, CORE is I'll just give you a brief on what CORE is. It's an organization that was set up to bridge the gap between what in modern days, that difference between the spiritual and the scientific, as if they were different, as if they were diametrically opposed, when in fact the ancient traditions spoke of them as the illumined, who in fact knew that they were one and the same. And we are privileged today to have with us Professor Benedikt, who has traveled from Belgium. I would like to say that he's come for us, but he's come for more than us. He's come here to, and he has a presentation that's very interesting, that in fact brings together exactly what we're talking about, which is he's going to present quantum physics and its association with Hermetic principles and philosophies and teachings. So here we're showing we're talking about science and spirituality being one and the same, not diametrically opposed. I'll leave it to you to.
Thank you very much for the kind introduction. First of all, thank you very much for having me here. It's an honor, it's a privilege. Lebanon is a very rich country with a lot of historical sites and a long cultural tradition. So it's I'm very happy actually to be here. And I have to just say next slide, I suppose. So this talk is going to be on the principles of Hermes and the influence of Hermes in, first of all, Alchemia, which then transformed to chemistry, modern science, and then through modern science and physics, now new theories are being formed, theory of everything, where again it's possible to broaden up the mind and again be amazed a little bit on the beautiness and beautiful nature and universe. So next slide, please. So as I mentioned, so first look a little bit at who Hermes Trismegistus was, and then his influences, well, from his writings into Alchemia, Alchemia becoming the strict science discipline of chemistry and physics, and then going into the string theory followed by M theory. Next slide, please. So in ancient times, the people were much more amazed when looking at nature, looking at the planets and the universe, and there was a nice harmony. So they didn't understand everything. They were amazed, and they had this sense of that there's something more between heaven and earth. Now, over time, this feeling got lost, so we got a little bit stuck in a very materialistic way of thinking, and everything being related to matter. So we got stuck in matter with little openings to being amazed and having a sense of something higher. And hopefully with these new trends and new findings in modern physics, perhaps it opens up again possibilities to be amazed again and have some sense for some spirituality. Next slide, please. So who was Hermes? Some people believe he was a person. Other people thought he was a merger or a hybrid between the Greek god Hermes on the right upper side, for you left, and above me the Greek god, the Egyptian god Thoth, the god of knowledge. So it was a hybrid between the Greek god, the Egyptian god, and also the Canaanite Phoenician Eno or Arnak, hence the epithet thrice great. Now, it could also refer to being Hermes, the greatest king, the greatest priest, and the greatest philosopher. Now, other people believed he was a real person. Teaching to Abraham or Moses, or even much older. Next slide, please. So Clement of Alexandria stated that the Egyptians had about 42 writings explaining the training of the Egyptian priests. Now, all these writings are known under the term or the group of Hermetica, but actually it combines multiple authors, all referring to or using the name of Hermes Trismegistus. There are two very important writings. One is the Corpus Hermeticum or Poemander, meaning the shepherd, and Asclepius, the perfect sermon. There are much other writings on Hermes. Next slide, please. For instance, the Kybalion. The Kybalion, some authors or researchers believe that this was a teaching given by Hermes to Abraham. But actually the Kybalion was published in 1908 by the Yogi Publication Society, and actually the same address of this Yogi Publication Society was actually the Masonic Temple in Chicago. And here actually you have a very nice summary of the main principles of Hermes and two additional ones. Next slide, please. Here you see the 7 main principles. First principle, mentalism, all is mind, and with a little extension, all is energy. The second one, correspondence, as above, so below, and vice versa. And in some of the tarot card decks, you see the magician standing with the hand up and hand down, referring to this correspondence. Very important, referring to the later explanation on string theory. Everything is vibration. Everything moves. Yeah, the table here, if you really good look, everything moves. Everything moves. Another one, polarity. Everything is dual. You have positive, negative. You have good and bad. So there's duality in everything. Also rhythm. There is rhythm in everything. Some companies get formed, they rise, and sometimes they decline. People get born, they grow up, and people die. And sometimes it's also referred to, history repeats itself. Unfortunately, man does not always learn from history. Next slide. Also cause and effect. Cause and effect, every cause has its effect, and the effect can be a cause again. So we get a continuation of wrinkles in the system. Actually, it's also sometimes used in modern technology, modern systems to analyze mistakes, like the Apollo root cause analysis is based on this, where they look at cause, effect, cause, effect, cause, effect, in order to understand the main problem if some disaster happened. And then the principle of gender. Besides the polarity, you also have the female and the male part, the soft and the strong. The two more additional concepts were transmutation, is that you can change one thing to another through transmutation. It can be material, and then we're having this practical alchemy. alchemy that takes place, or mentally. You can also transmute mentally. And then the last one, that there is an innate truth. There is everybody has a strong feeling if there is something really true. So the substantial reality is the ultimate truth. Next slide, please. Another important writing dedicated to Hermes. I'm trying to stand here in the camera. Is the Emerald Tablets, or the Tabula Smaragdina. The oldest reference is going to this 8th century book, Arabic book, The Secrets of Creation and the Art of Nature, by Jabir ibn Hayyan. I hope I pronounced these names in a correct way. In Latin, he's referred to as Geber. And English gibberish is actually coming from this, because sometimes it's quite heavy, very rich words that has been used, and using what's called technama, so talking in code and symbolism, which is not always that clear. So often now the English expression is gibberish. It doesn't make sense. For somebody who doesn't know, it doesn't make sense. So gibberish. But these Tabula Smaragdina has been very influential to a lot of scientists through the centuries, and a lot of philosophers. Isaac Newton, Kepler, Leonardo da Vinci. They are all inspired by Hermetic writings. Next slide, please. Here you see, because Isaac Newton did not only study physics and wrote his most important work, the Principia, on modern classical physics, but his main passion was actually alchemy. So Isaac Newton has been doing quite some alchemy, and he also translated the Emerald Tablets. You see, I'm not going to read it, but you can read for yourself. I'm also sure that the slides will be shared among the audience. And here you see again some of the same items from Hermes. That which is below is like that which is above. So here again, as above as below, the correspondence. The principle of rhythm, the principle of duality. So it's all also present in the Smaragdine table. Next slide, please. Then we have another writing from or related to Hermes, or actually Thoth. So it's the Emerald Tablets of Thoth the Atlantean. Okay. Atlantean, good. It was translated by a certain Dr. Dorial in 1925, who went to Tibet and some other areas in the east, and he got the task of retrieving these tablets from South America, bringing them back to the Big Pyramid in a translated form and leave them there. It seems that he did so. But you have to be a little skeptical on this. He's telling that these tablets are 50,000 years old. He's very old, right? So I don't know. So they're green tablets kept together with hoops of golden-colored alloys. So on the upper, from my right side, you see a picture of the cover of this book with emerald tablets and the golden coins. And this Dr. Dorial found in the past what is called the Brotherhood of the White Temple, which is linked to the Great White Lodge with the headquarters in Shambala. Where the hell is Shambala? Somebody know? If you go looking and doing a little research, you then move to something which is very strange. And that's on the next slide. Shambala refers to Agartha, and there are some theories that Earth is hollow and the other planets are also hollow. And Shambala is this region here in inner Earth. You had Admiral Byrne making stories about that he moved in and so forth. So it's very strange, but it's appealing. It's a nice story to read. It's also was part of some ancient traditions, like the Egyptians talked about the hollow earth, or the Tibetans and Indians. So now there is some conspiracy theory stating that the flights are not allowed to cross over the North Pole or under the South Pole. Could be very simple, because the compass could be behaving strangely, because it's stuck directly at the north. And then you have some pictures from ISS where you also saw some strange form. So if you want to read a little bit further on that, be my guest. It's exciting, but very important. Please look at it in a very critical way. But anyway, so that was also some text related to Hermes. Next, please. So Hermes and Alchemia. So first look at Alchemia. We have to go back to the Hellenistic Egypt after Alexander the Great. And Alchemia is actually a union between the very practical, hands-on work of the Egyptians. For instance, the Chrysopoeia, it's the making of gold. And then the theoretical speculations of the Greek related to the nature of matter. So it's this Greek philosophy merged with the practical experience of the Egyptians. And this is how Alchemia came about. The Greeks refer to chemia as the art of the people of Egypt, and chem was also black, referring to the black soil of the Nile, which was very fertile. And then it was further developed in the Arabic world, and the Arabs added the prefix al, giving thus alchemia. So this is how Alchemia came about. Now, okay, I'll come to that a little bit later. So next slide, please. And in Alchemia, they have this concept of, and here I refer to the first Hermetic principle, all is one, all is mind. And then already Thales of Miletus mentioned that all substances come from a primordial basic substance. This type of thinking is called monism. So monism is looking or considering or accepting the fact that everything comes from the same base material. It's often symbolized by this strange fellow here, a snake eating its own tail, and this animal is called the Ouroboros. It's a concept already known by the Egyptians in the 14th century before Christ, a long time ago. And you can find it, for instance, already this concept on the grave of Tutankhamun. And here you see hand to palm, one is the all. So therefore, the snake eating its own tail. Next slide, please. Now, Thales inspired very much other philosophers like Pythagoras, who expressed this manifestation of the different elements based on a pentagram. So you have earth, water, air, and fire, and also the fifth element he called ether. The Middle Age, or in the Middle Ages, the alchemists called also ether quint, from 5, essence, the fifth element. Of course, in the pentagram, you probably know this ratio gives you the golden section, which you can find, it's phi, in a lot of areas in nature, how man is built, the ratios in men, the ratios in the temples, the ratios in certain plants, animals, and so forth. This number, phi, also is linked a little bit to what I will be talking later about Planck's length, the minimum meaningful length. And as I mentioned, I'll come to that later. Next slide, please. Now, Pythagoras also believed that everything was music. Everything has vibrations. And every type of matter had their own tunes. Pythagoras used music also to heal the body and mind. And Pythagoras told the priest that he could hear the harmony of the spheres. So the spheres and the planets are moving, and he could hear that. Now the funny thing is, and I'll come to that later, that very recently it was the first time that they could observe gravitational waves. And the gravitational waves also make sound. And so it was nice that Pythagoras already was thinking of matter being vibrations and music. Everything is music. It's a nice way of thinking. Everything is music. And the Schumann resonances, so these are very low frequency resonance, they calculated that the fundamental frequency of planet Earth is 7.83 hertz, and then if you add some octaves, you get to 432 hertz, which seems to be a very nice melody where people feel quite comfortable because it's in line with basically the fundamental frequency of Earth. Yeah, next slide, please. Now, after Pythagoras, you had Aristotle, and Aristotle associated these elements also with the male and the female, active and passive, positive, negative. And this is actually the Hermetic principle of duality and polarity, energy and matter. The philosophical Mercury is the wet and the cold part. The wet and the cold part. The philosophical sulfur, and I'm calling it philosophical to distinguish between Mercury, the element or the planet, and sulfur, the element which can combust and is this yellow smelly thing. So philosophical sulfur is the hot and dry part, male, female, active energy, passive energy. And actually, it's this combination between the mercury and the sulfur in different proportions and different purities that gives rise to the different elements and to the different metals. And by changing these combinations, you could change the metals, which has been achieved in modern chemistry. And I mentioned, I'll come to that a little bit later. Next slide, please. So the ancient cultures considered there were 7 metals. 2 noble metals, because they were less sensitive to acids and oxidation, so they're more stable. The noble metals, silver and gold. And then 5 less noble metals, being tin, mercury, copper, iron, and lead. All linked to a certain planet, and also later on linked to certain orbits. And that's again in line with this concept, as above, so below, universe as a microcosmos, man as a microcosmos. And they believed that one metal, or the lower metals, could be transmuted into the higher metals, into silver and gold, by changing these proportions and purity. Next slide, please. Also, about interaction of this male and female force, as for instance you see here, the sulfur and the mercury, the male and female force, active and passive, they merge into what's given then the Solomon seal. And this merger is done by the force of love, as Empedocles mentioned earlier. It's also expressed in the rebus. So the rebus is res bina, meaning dual matter. So you have duality in all matter. And actually, this is a picture. It's a pity it's not clear, but this is the supermoon. I was very lucky that I was airborne on November 14th, flying to Cambodia, and everybody was asleep. And I was watching outside the window, reading, preparing for this presentation here. And then suddenly everything started turning blue, beautiful blue. And I looked outside, and you see here the moon. And the moon was so bright that it started to look like a sun. So I said, this is a nice principle. You have this matter of the moon, which is cold, and the sun, this male part, was shining on the moon, the female part, and it started to become its own star. And everything was blue, and deep blue. So it was fantastic. Next, so as I mentioned, it's the merger of the craft traditions from the Egyptians and the philosophy from the Greeks. And this was really established around 300 AD. And you had a very important person, Zosimos of Panopolis. He wrote many, many books on Alchemia, but including some very practical ones. He already had a real scientific approach to making observations and writing down and analyzing and seeing certain trends. He also wrote books, for instance, on equipment. You see here some distillation equipment. So it was already very practical. Now, Zosimos also used very coded and symbolic language, which later on was even more established, and then you had all the symbolism from alchemical books. Zosimos clearly considered Hermes as the father and founder of Alchemia and other Gnostic spiritualities. And the following 500 years, Alchemia was much more evolved in the Arabic world. And I already mentioned Jabir ibn Hayyan, but actually probably this was not also one author, one gentleman, it was a group of gentlemen writing about Alchemia. By the 17th century, so around 1100 AD, people took this Alchemia and this knowledge to the West, where it further developed. In the beginning, it was very hush-hush because it was not allowed. It was considered Hermeticism, and people got burned on the stake. But it was good knowledge, it was scientific knowledge. But then by the 17th century, in the West, Alchemia was much further developed compared to what was given initially coming from the Arabic world. Next slide, please. Most of the 17th century work still dealt with metallic transmutations and metallurgy. And this, of course, using a catalyst in order to transform these metals to gold. And you had a white philosopher's stone, white catalyst that could transform or transmute the non-noble metals into silver. And you had a red philosopher's stone, where you also produce a red lion, to convert base metals into gold. Now, actually, there is a good nugget of truth in what they've done. They actually could make gold from lead. And you know how they did that? Ever heard about the product stibnite or the ore stibnite? Okay, so ore stibnite is present in Egypt and other areas, and there's a high level of lead and tin. There's this fatty, which they start working on, but in this fatty ore, you have also quite a high percentage of gold. So basically, they were doing really metallic transformation, purifying basically the gold out of the stibnite. So they were making a type of lead into gold because the gold has always been inside the stibnite. But it was quite dangerous. Some people got exploded. So what happens is they made ammonia and niter. That's why you have temples from Egypt, Ammon. Ammonia comes from the temple of Egypt, Ammon. And they had this saltpeter, so nitrogen-based products. The stibnite is antimony sulfur compound. And then, of course, if you use carbon and you heat the whole thing in order to, then you have carbon, sulfur, and nitrate, and this gives you, it's a black powder. So probably this is how black powder got invented by an alchemical experiment that went bad. Okay, but also in those days you had quite a lot of work related to preparation of medicines. It's called chemiatria, and the most important person who contributed there was this gentleman here, which was a Swiss physician, Theophrastus Bombastus von Boerhaave, also better known as Paracelsus. You know where the English term bombastic comes from? It's from this gentleman. This was Mr. Bombastic. This was Mr. Bombastic. But he did quite a good job because he was the founder basically from toxicology. He mentioned the following phrase: the poison sits in the dose. So this phrase, actually, this insight comes from this gentleman. So actually, he was the founder of toxicology, modern toxicology. Yes, next slide, please. Paracelsus, it's making now everybody confused a little bit. Sometimes it's difficult to follow what's now sulfur, what's now mercury, and then they start changing stuff. So it's difficult to follow. It's actually also due to Paracelsus because he added salt, the philosophical salt, next to the sulfur and the mercury. And this is then what's called the Tria Prima. So you had a combustible sulfur, which is actually soul. If we light incense, the incense is actually expressing this concept of soul. You had a fluidable, changeable mercury, fluid, changeable, that's the spirit. That's the light, if you light a candle. And then what's everything, the solid permanent that stays behind, it's the soul. It's the body, the matter, or the caput mortem. Everything which is that's the caput mortem. And then according to Paracelsus, sickness and health are related to the harmony of man, the microcosmos, with nature, the microcosmos with macrocosmos. So there is a nice balance. And the organs in a body are considered the same as the planets in the universe. Some nice pictures. Here you see the golden chain of Homer in relation to the Tria Prima. And as I mentioned, so Paracelsus has now salt, sulfur, mercury. Mercury being, like the god Mercury, the messenger between the world of the gods and the world of the mortals living here. And everything starts from chaos, giving the celestial salt, the fixed, the female part, and the celestial nitre, which is the volatile part, the prima materia, resulting in earth, water, air, and fire. Okay. If there are some strange things, we don't, please stop me and then ask, and what are you talking about? Can you explain a little more? Okay. Next slide, please. Now, over time, during the...
Sorry, can we go back to the previous slide?
Yes. So
from chaos, we break out into the celestial soul, and then the celestial...
Or actually the prima materia, so they're a little bit linked. So you can chaos, you get this, you combine, or you can split this up, and from those you get the earth, water, air, and fire.
So what caused chaos to go from chaos to the prima materia?
Energy.
Right. Where did that come from?
You can ask some questions, and I have to admit, I don't have the answers to all your questions. Where does this energy come from? Then we get very philosophical, where does the ultimate, who created order out of chaos? So there are still a lot of questions, question mark. Okay, next slide, please. So by the mid-18th century, Alchemia became a relic. It was something for swindlers. And we turned into the very base scientific discipline of chemistry, which was following matter, studying matter according to very strict laws. There was no room left to have some philosophical or some spiritual insights in what happens here. So it got despiritualized. There was a little bit of a revival of alchemy due to the formed secret societies, where you had the Rosicrucians, mainly in Germany, you had the Freemasons, France, England, and then you had a strange couple of guys called Illuminati. You have Illumined people, but also have Illuminati. Okay, we can talk about that a little bit later after the presentation if people are interested. Nevertheless, in modern science, the strict scientific discipline, you still find several of the Hermetic principles. Next slide, please. For instance, table salt. Now I know for some scientists this is simple. Perhaps for non-scientists it's not so simple. I tried to make a presentation without too much mathematical equations, which was very difficult to do, especially for the string theory and the M theory, and not too strict, very fundamental scientific laws and rationale. So it's, but I hope it went okay. So we have table salt, where you have this positive ion, cation, sodium, and you have this negative ion, chlorine, and these combine and you have table salt. Also an atom consists of a positive charged nucleus, this thing here, this is a carbon atom, where you have neutrons, they don't have a charge, and protons, the red ones here, they have a charge. And then you have these electrons spinning around. and it's difficult to measure. You have the Heisenberg principle, so they don't like to be measured, they're really analyzed. So 6 negative electrons, 6 positive protons, and these actually are all the ingredients that are referring to the sulfur and the mercury, we combined in different purities that give rise to different materials. If you play along with the different neutron levels, proton levels, and electrons, you end up with a nice table of Mendeleev. So these are the building blocks that give rise to all the elements in the table of Mendeleev. Keep in mind that this is very small, 77 times 10 to the minus 11. It's very, very small, and I'll try to explain how small it is a little bit later. Now, actually, the dream of the old alchemists came true, because before 98, they could bombard lead with higher velocity particles, and they made gold. But it was not stable. It was not a stable isotope, so it fell and broke apart again. But then this gentleman, Seaborg, in 1980, produced gold by removing some of these elements from bismuth and had a stable gold. It was a stable gold. Now, unfortunately, in order to remove neutrons and protons from bismuth, is costing much more than just digging up and finding the ores where you have gold inside. So, but anyway, so here the old alchemist dream has come true. So they can actually make gold from bismuth or from lead. Next slide, please. And then on a macro scale, so this was quantum physics, digging in, looking at the small particles of atoms. From a macro scale, all is light, all is energy. We had Einstein's theory of relativity. And here, clearly, the relation is set. Energy equals mass times the speed of light to the second. This means that if you convert all the mass completely to energy, because we don't do that, only small part is converted to energy. But if me, myself here, 85 kg, more or less, and convert myself completely to energy, I have the power of several nuclear bombs. But it doesn't happen. So not all matter is completely converted into energy. But here clearly you have the relation: energy is matter, matter is energy. And also energy and matter can be linked to order and disorder, or order and chaos, via thermodynamical concept of entropy. And also nowadays with the M theory, you can look even at entropy at black holes. And, the M theory can explain black holes. Next slide, please.
Sorry, we can think of this also, the c squared, as frequency, because it's an expression. So energy and mass are the same,
yeah.
And frequency determines how energy is expressed in terms of mass.
Exactly, and depending on the frequency and the wavelength, you have, and that's all related then back. But I'm now coming to, I think, in the next slide. No, not yet. But I'm coming to that on when I explain the strings. So quantum physics describes matter on a micro scale, the constituents of atoms, of quarks, and so forth. And then you have the theory of relativity describing the matter on a macro scale, universe. So at the end of the 20th century, physicists started to looking at a unifying theory, a little bit like Hermes, a little bit like alchemy, joining two things. The theory of everything. And it was these three gentlemen who were granted the title of being founder of the superstring theory, where they stated all particles are not solid balls, like when you shoot pool, not balls, but tiny vibrating strings. So all matter are tiny vibrating strings. Next slide, please. The string theory also aims to unify the four main forces: the strong nuclear force, active on a very small distance, keeping the nucleus together; weak nuclear forces, where you can start looking at nuclear decay, radioactive decay, Electromagnetic force, a little bit longer, active on a longer distance, and then gravitational force, the dominant force over long distances, referring to galaxies and planets. Next slide, please. So, and here we have the Pythagoras, he already came up with this. So you could look at material, matter, the basic tiny particles as a string. String length and wavelength, and they vibrate. And here again you see the positive, the negative, the duality, and then you have minimum displacements called the nodes, and you have the antinodes where you have maximum displacement. And the wavelength and the frequency determines how much energy is present, and whether you can look at more energy or this type of matter or this type of matter. So the matter has different frequencies. Next slide. So matter can be looked at a manifestation of standing waves on tiny strings, and tiny, they are very, very tiny. Different vibrational modes give them rise to different particles. Now, this is actually referring to Hermes, the Prima materia, all is one. So all goes back to these strings. Now, to get a little more complicated, strings can be open and strings can be closed. If strings are open, they can move into other planes. Now I'll come to that a little bit later. If they're closed, they're attached to branes. I'll explain that a little bit later as well. Now, how big are these tiny vibrating strings? They are really tiny. They are called the Planck's length. So it's 1.62. You see the golden section number. 1.62 multiplied by 10 to the minus 35th. This is really tiny. And now try to give some idea on how tiny this is. The next slide, please.
Is it the same as the Planck's constant?
No, that's different. Planck's length is the minimum useful size or accepted size. But Planck has a lot of. So if we remember our tiny carbon atom, 77 times 10 to the minus 11. If we magnify this many times to the size of our Milky Way galaxy, it's 100,000 light years of 9.5 10 to the 20th meters. So this atom to this size, and we do the same magnification with our string, we end up with something less than a millimeter. So hopefully this gives you some feeling how tiny this thing here is. Okay. So, and we don't have momentarily the scientific equipment to look at those sizes. They recently have done a good job stating that a quark they know is now for sure already smaller than 10 to the minus 18. But they can't measure any smaller things. So they know it must be much smaller than that, but it can't go lower momentarily than minus 10 to the 18. Next slide, please. For the string theory, now we go multi-dimensions. So there is much more than meets the eye. For string theory, we have nice space dimensions, one time dimension. And for a dimension, it's a bit strange, but you have to look at the dimension as a degree of freedom. So if I have 3 spatial dimensions, I have 3 degrees of freedom. I can jump, I can go down, I can move to the left, I can go to the front. So I have several degrees of freedom in this 3-dimensional structure.
And only one time dimension.
Sorry?
And only one time dimension.
At the moment, but that's also changed. Sometimes you have M theories looking at 2-time dimensions and then completely lower. So this is already. It's not so easy to grasp the fact that there are more than 3 space dimensions. And this, so basically, string theory, M theory, is a fundamental mathematical, physical theory that can explain a lot of phenomena. So here you see a point at the time 1, which can be described in a 3-dimension by the different Cartesian coordinates. Here again, Cartesian coordinate. And this point moves, poof, and is at this place. So at the second time. So we can really describe in 3 dimensions at a certain time where this specific point is. Okay, just to give an idea, 3 dimensions. Now space dimensions. Next slide, please. Now, where are all these other dimensions go? So some scientists say that these dimensions, these extra dimensions, curl up into a very tiny, tiny place, and we know our tiny place being the Planck's length. This is called the Kaluza-Klein compactification. So basically, we have a whole set of dimensions moving to this tiny Planck's length. So there could be a whole bunch of other dimensions small. It can also give rise to the fact that the other dimensions are extremely big, with a restriction of all the matter and energy being located in a subpart of that space. And then there's another theory that fits also with the M theory, giving rise to parallel universes. So that besides our universe, there are parallel universes. I know it's quite inspiring, so it makes you think. Eh? So next slide, please. So the string theory, and then again with the duality and gender. String theory requires supersymmetry. So for all female part, you need a male part. They have to go hand in hand. And talking about these male and female parts, you have tiny particles called bosons, which are the carrier of force. For instance, photons carry light. That's light. Gluons, like glue, that's what keeps the quarks together in the nucleus. Fermions are the particles which are the solid. That's matter. And so for every boson, you have a fermion. They go hand in hand. They combine, it's called hadrons, but okay. And then actually a quark, one of the constituents of a nucleus, so a proton can be considered as a knot with 3 quark strings. But we don't know exactly how big this quark string is. Assume it's Planck's length. There is no smaller thing than a Planck's length. Some people think we can go to 0. It's not possible. It's also required because in the maths related to string theory and M theory, sometimes you have to divide by the length. And if you have a 0 length, you end up with infinity. Exactly. That's a problem. You end up with infinity. So bosons can be looked at as the male force. And to be honest, there is no bad between force and matter, and so let's call the male force, and fermions the female virgin bond. So you have a whole set of fermions and you have a whole set of bosons. Next slide, please. Now, people were very happy with the string theories, but over time, there were 5 string theories. You had type 1, type 2a, 5 string theories that, oh, it's rubbish because we have 5. Until they noticed that if you consider 2 dualities, the topical duality, it's looking how spaces from different shapes can be related and can actually be considered the same. And as duality, looking at the strength or the weakness of strings to break apart or to join with other strings. And basically, these 4 variations of the string theory are all images of the same. They can be correlated to the same thing. And this is how we end up with the M theory. And the M theory I'll try to explain in the following slides. Yes, please. So Edward Witten, 1995, proposed a solution regarding this problem of these 5 different types of string theory. And for this, it was based on these dualities, he introduced the concept of membranes, or branes in short. So next to one-dimensional strings as the fundamental building blocks in the universe, we now have another body called the branes. And these branes are multidimensional objects which can take various shapes. You can calculate a tremendous amount of different shapes, which can fit also the laws of our universe. So, and they're still figuring out if now with perhaps quantum computers, it can help really to identify which type of shapes could work. So branes exist within the full 10-dimensional space, but the string theory, and then one time dimension, or sometimes they also talk about already 2 time dimensions. Branes can also have a charge, and this is important because this is also the key how they explained black holes. Next slide. As I mentioned, they can have a charge or a tension indicating how resistant they are to interactions or other influences. They can have a 0 dimension or 9 space dimensions. And these are then next to the strings, one of the other fundamental objects that make out our universe. You see here 2 branes, 2-dimensional branes, and then strings can attach to it. Yeah? They can attach to the 2 branes, 1 brane, and you see here also closed strings. And these closed strings can move through branes. Next slide, please. And a graviton, that's a boson, carrying the force of, carrying the gravitational force. And that's such a string which is closed. Normally, gravity should be a very, very strong force, but we actually only perceive it as a weak force. So it could be that one of the vectors of this force through this graviton is sticking outside in another dimensional plane. So that's one. And now on February 2016 was the first time at LIGO that they actually could, was great news, they could identify and measure a gravitational force. So the gravitational force has been proven, is existing, and it was related to, far away from here, there were 2 black holes twirling. So when they're moving closer, so the black holes start twirling closer and closer until they merge. And due to the fact that you have these very high masses twirling, it's sending out gravitational waves. And there is actually a sound. So if you go to, there are some references also in PowerPoint, you can go to some of these references and you can hear the sound of the gravitational wave. It's like a pulsing hum. So it's nice to hear, and it reminds me of the fact that Pythagoras mentioned that he could hear the harmony of the spheres. Anyway, so there is a lot of new research made available through this side of systems, but also at CERN, where hopefully they now try to see if they can identify a graviton or a graviton moving out of this dimension, getting lost, so being proof of the other dimension. So that's all experiments that will be taking place in CERN in Switzerland. Next slide, please. So the Hermetic principle of duality and polarity has been addressed several times. So sometimes we talk, looking at Hermes, about this polarity and extremes. Are there absolute extremes? Is there something like hot, cold to the extremes, good or bad, and so forth? Now, let's take the example of hot and cold. You have, besides Fahrenheit and Celsius, another temperature scale called Kelvin. And the absolute 0 Kelvin is at minus 273.15 degrees Celsius. And at that point, everything freezes. That nothing moves anymore. So this could be like the absolute cold, absolute cold. And at this time, you have a Bose-Einstein condensate, where everything is fluid. So, as I mentioned, atoms in a whole can be considered as wave packages. And then when they are reaching 0 Kelvin, these small wave packages of the atoms start overlapping. And at 0 Kelvin, you can't distinguish any atom from another anymore. It's all the same, it's all one wave. Here you see how they all compact and become very, very identified, and this is only at 5 nanokelvin, because that's another thing with helium. You can't actually, in practice, reach absolutely 0 Kelvin. So there's that theoretical concept, but you can't do it. You can't reach the organ. Now let us look at the other hand, to extreme temperatures. And then we have to look to the actually what happened at the Big Bang. And these extreme temperatures, it's called the quark gluon plasma. This is microseconds after the Big Bang. Very extreme temperatures, and then quarks and gluons, they are not linked together. If they merge, it's a high hadron, but they exist separately, and they're behaving as free particles. And in 2010, scientists claimed that they actually were able to generate a quark gluon plasma having a temperature of 4 trillion degrees Celsius. I think this is very hot. It's very, very hot. So this is seconds after the Big Bang. So but they managed to get this extreme temperature. So perhaps there are a little bit sometimes more or less some of the extreme. Next slide, please. Now, if you really want to understand all the fundamentals of string theory and M theory, you have to dig into really, really tough maths. Very, very tough maths. It's not easy. And then you fully understand it. But then you also see the loopholes. It's perhaps still not yet perfect. And you have other alternatives being formulated, like the F theory or the quantum gravity. Some people are really in favor of the M theory, some people are against, and they say, well, it doesn't prove or nothing or too much. But of course, the further studies at CERN and other labs can actually perhaps later on give some more insights whether or not the theory is correct. But one of the merits already of the M theory is it could explain black holes. M theory was not designed to explain black holes. It just happened that the theory was formulated and explanation for black holes was part of that theory. So that's a nice merit. So next slide. So black holes are formed when stars die. And they start accumulating mass. And it becomes so heavy that even light cannot escape anymore. At the point where light is absorbed by the black hole, that's why it's also not emitting light, it's called the event horizon, and all the light and energy gets sucked in. Now, this gentleman here, Stephen Hawking, noticed that black holes emit radiation. If they emit radiation, they're also heating up, losing energy, losing mass, and then actually, if they're not fed more mass, they start evaporating and becoming smaller and smaller until they reach the Planck's length, and then what? The problem, because they say, well, it's the smallest meaningful size, and then Steve Hawking said, well, it's going to be, it bursts and sends out all the left energy and matter. But this gives a problem, and this problem is, next slide, called the paradox of the black hole information. So now quantum mechanics do not allow information to be lost. Information is order. If you have information, you have order. And the information is lost means that order is lost and that entropy or disorder increases. And actually, I'm not going to give all the details because it's very complicated. The M theory provided a solution for the black hole paradox by combining some of the branes. And this combination of these branes could explain everything what happens with a black hole, but at this moment only for a very specific type of black hole is a charged black hole. And it was using one brane in combination with a 5 brane. But also, and it can be linked to the multiverse concept, stating that matter and information that enters into a black hole is passed from this universe into another. In the theoretical model of M theory, you can explain that. So now, besides our 3 dimensions and 1 time dimension, we see information going to other dimensions in this theoretical model. If you start thinking too much about it, you get a headache. So anyway, next slide, please. The M theory also can explain the Big Bang. We started with a tiny element of high energy, it exploded and matter was created. But also the Big Crunch theory. stating that after a while, everything, after expanding, starts at a sufficient mass to contract everything again, to a small tiny thing where everything crunches together. And then you have the big bounce theory, which you can also find also, for instance, in the Hindu philosophy, and the Hermetic principle of rhythm, that Big Bang, everything explodes, everything contracts again to a very strong energetic particle, and it explodes again, and everything starts again. So you have this rhythm of explosion, contracting, explosion, contracting. And this is not, of course, overnight, and this takes gazillions amount of years or light years. Next slide, please. So, as a conclusion, over time, people were really, in the past, they were really looking amazed at the planets and feeling very in harmony with their body and nature. We got lost that a little bit over time. Our sciences became very materialistic laws with very little room to still be amazed and have this sense of some higher dimensions or higher force. So perhaps with this theory of everything, and this M theory can help man and to get a mindset of being again amazed and understand that there's a little bit more between heaven and earth, or something more that meets the eye. And perhaps this little by little we can find again some spiritual insights in this and get back in harmony with the body, the planet, and the universe. This being said, so that's the references you have to read if you're interested. And I think this is the end. And if there are questions, I'll try to answer them.
Thank you. So we're here for some question and answers. Anyone have questions to ask?
Yes?
What's the difference between soul and spirit in Hermeticism?
Soul and spirit. Well, I can very easily go back to the chain of Homer. So soul is, can you go back? But that's a tough philosophical question.
Okay.
From an alchemical perspective, it's more easy. Then, no, further down. Yes, up one up. So you have the salt, earth and water, matter. Then you have the sulfur, that's the soul. And actually in plants, it could be explained nicely in plants. If you take a plant, a herb, and you do a dry distillation, air and fire, or a little bit of a steam distillation, then you get the essences of the plant, the character, the soul of the plant. Like it when it's present thyme, is the essential oils. It's what smells. So this and thyme, if you smell, oh, this is thyme. Take another herb, oh, this is oregano. Take another herb, this is garlic. So the soul, the sulfur is the character, the identity of that specific item. Then, if we put it into a fermentation, this herb, and we let it putrefy, then it starts fermenting. And then you distill, and actually the alcohol, it's actually the spirit. This is the higher thing, it's the spirit. It's the life force, that's why, for instance, in plants and in spirits, it's called eau de vie, water of life. So this, and the water of life, or eau de vie, for all the plants is the same. So it's the spirit carried, and it's the same amongst the plants. Then if we've done all the distillation and the purification, then we're ended up what's called the capus mortem. It's the dead material where the soul has been gone, the spirit has been gone, and we're left with the matter, the body. Then you can calcify and burn and get ashes. And then of course, the ashes of the earth, you dissolve the ashes again, and then you have the salt. So the ashes, you have nitrates there, you have carbonates there, so they are soluble, and then you take the water, evaporate, and you have white salts. So that's the body, the material. And then what Paracelsus did is the concept of spagyria. it's like man doing a little bit improvement of evolution. So you take apart from plants all the essentials, you purify them, and you bring them together into a better product. I know it's a little metamorphological, philosophical, but talking about soul, so it's the identity, the spirit is the higher value, which is common in plant world, and the soul is the matter, the body, which
The pure materiality of the body.
is the matter, which is then, and actually you take the soul, and then and that's the female part, you put the soul and the spirit back together, and this is Nigeria, and then you have again life soul. Yeah. Is that somewhat understand? Okay, you're welcome. Yeah.
I have two questions, please. I will start from. Okay, you said that in February 2016 it has been observed the first electromagnetic or first gravitational force, exactly.
Yeah.
I didn't understand. Please, would you explain?
Okay, Einstein predicted that there would be gravitational force, so that big masses send out a force, gravitational force. And so this force, what was measured, was caused by, and these waves were caused by the fact that there were two black holes swirling, so huge masses moving around, making wrinkles in space-time. And so they identified, long after Einstein predicted, but he had some problems with it, that gravitational forces exist. Now, they're very long wavelengths going through all things, and this now opens huge opportunities to have better insight in the universe, because now we observe the universe through light. But the light doesn't pass other matter, and the universe is full with stuff, and it gets scattered. But gravitational forces go through matter. So now we have another way of observing things in the universe.
Okay.
So, but you have light, which is photons, and you have gravitational waves, which is gravitons.
Okay. And it was the first time to see
It's the first time. Yeah, it's the first time. So if you have gravitational waves, this is already the first step to prove that there are gravitons.
Okay.
But there we're not yet there. We have to see something escaping through another dimension in CERN. But then we know we have gravitons. But it's not for tomorrow. Yeah, the second question.
Yes. Second question. What do you wish to explain or to clarify for you, if you was chosen to explain something in the universe? What do you pick? What do you wish to know, to formulate, to put a theory?
Ooh, I want to wish
one thing.
I want to know a lot, but,
no, but one thing.
I don't know yet a lot. But for me, this you can ask my wife. I was when I was going through string theory, I was like, oh, I was walking around and I saw everything as strings. It was like but it gives you a better understanding, and it allows you again to be standing amazed to nature and universe and know that there is something more than what we understand and than what meets the eye. So for me, it's also a way through science and through this maths. For me, maths is you can consider it as a language of the gods. Pythagoras used it because it allows us also to think in an abstract way. All the dimensions and spirits and the big force or the one is very abstract, and maths also allows you to think in an abstract way. So for me, I'm very happy already that I gained a little bit more insights and I can stand amazed to the universe and nature and perhaps feel a little bit more in harmony. And yeah, I mean, but that's my, so I can give you my story. Perhaps for other people it's a different thing, but for me, science can be a nice channel, and that's to really understand a little bit more.
Okay. And we have questions from Core in Lagos. They are, do you subscribe to the theory by physicist Haramian who claim that the perceived anti-physical space is filled with many black holes, filled with massive energy.
This basically goes to this condensation where all these extra dimensions are curled into something smaller than a Planck length. So can be could be considered as a black hole. But then if we move to that level, then M theory of physics becomes again a little bit of philosophy. So I can relate to that, but I'm not going to state this is the absolute truth. There are still so many unknown things that there are different views. Like a view on matter goes into a black hole and it's absorbed, and there is the information goes that this black hole is then, to be very simplistic, the black hole sucking in light could be transmitting light on the other side like a sun. So, but, there are many people looking at and different, but this is in line with what I mentioned. These extra dimensions curling up to something at the size of a Planck length. But now stating this is absolute true, I mean, I don't claim nobody has the ultimate
But this
truth.
is a possible.
It's a possible, yeah, it's one of the possibilities.
Sorry. Good.
On duality, touched on duality and entropy. And in duality, you have optical, forward, backward, up, down, time. How do you explain where does time come in duality? There's forward, but there doesn't seem to be backward.
There is backward. You can go to Einstein and you could go backward.
But how come we don't experience it?
Because we have to. Because then we should be able to travel at the speed of light. But when you travel at the speed of light, the more you get closer to the speed of light, the more heavier you get. So we at the moment we don't travel at the speed of light. So we don't. But there is a distance of height, and gravity has an influence on time. There was a nice experiment done where they stayed, so they had atomic clocks. One stayed really near the sea level, the other ones went very high up in the mountain, put up camp, and the time clocks were doing the same. And they came back, and there was indeed a tiny fraction of, because higher, you had a different, there was a different space-time than we had here at sea level. But then we were talking about 0.00000 something seconds, but it was statistically significant.
But we can see, everything that we look up into the sky, into space, is already, we're seeing it now, but it's happened further out in the world. It's happened millions of years ago.
We can be looking at the star, which isn't there anymore.
Right.
We only still see the light, but the star could be gone. So, yes.
I tried to follow what you said about the string theory, but I also heard you say that you cannot measure it at this point in time.
The size of a string, you can't
How do
measure.
you know it exists, and is it rather a string philosophy?
It's not a philosophy, it's a mathematical, physical model which fits and which can explain a lot of the phenomena which couldn't have been explained earlier. So this is entrance through maths. As I mentioned, maths is a very interesting language. It is not said if aliens would come to our planet, for sure they have to know maths. I think you should be. Are you a mathematician? I suppose. No.
I'm not
Oh, okay. But if aliens should come here, they have to have the concept of maths.
Something that's always puzzled me is that we talk that all matter is made up of small pieces.
Mm.
At what point can you observe, for example, a solid object as its small pieces and they are fluid? Because if you take this theory all the way to its origin, for sure you should be able to pass through a solid object.
Mm.
Because they're not actually solid.
No, but then you're at the.
So
then
is
you're
it
at,
possible to see that?
Yeah, but then we're all energy and we're not there because then we have to go all through this quark gluon plasma, where you can move through matter, but you're not going to survive 4 trillion degrees. Yeah, so that's no problem. Or we have this very dense, and that's also matter. The Egyptians, they already made a great observation. They stated matter is condensed light. Fantastic. But it's here, so we can't penetrate, or we have to convert ourselves into energy, and we penetrate through matter. But,
So you could,
no,
in reality.
not within this 3 space-time dimension that we experience.
What's the practical daily application of the
Practical
subject you just discussed?
Well, it's almost, well, you can have some practical things because now this is also the base for quantum computers that will be designed. For quantum computers.
Because I want to understand that.
Okay, so then instead of having one possible solution, you have a number of possibilities you can exactly at the same time address and analyze. It also can give explanation to some of the radiation we find, also to dark matter. That's another problem that needs to be solved, dark matter. And now models being based on Tria theory that also can explain dark matter and where dark matter comes from, where it goes. And the black holes is already a good insight. So it opens up new insights on the macro level, universe, understand better what's happening around you, and on a micro universe at a real tiny scale. And then they say, as Hermes, it's basically linked. By observing the universe, you get better understanding, same as you by studying the microscope. And this insight designs also experiments in CERN to see if they can set up experiments to prove, for instance, M-theory, string theory, or to identify, for instance, the graviton. If basically, that would be a fantastic experiment. We're not there yet. But if we do experiments and we can see the graviton moving and gone, it means that the graviton moved to another brane into another dimension, being then proved that there are all dimensions. So, would be nice, eh? But we're not there yet.
So if you take the quantum physics approach, where they analyze the particle of God, which is the most the tiniest element existing, which can be measured.
But that consists of even smaller particles. And these particles we can't measure yet. Because they can't, like a quark, yeah, that's one of the strings, basic strings, that we can't measure. We only know that it must be smaller than 10 to the minus 18, but it's significantly more small. We can't measure. So it's consisting of other items. If we can measure it, it's still not small enough to, it still needs to be broken down in even smaller particles.
But they did this experiment, where this experiment where they shot protons, into some tiny hole. And when they were observing this experiment,
Yeah. But that's a duality. That's a duality where the, for instance, for photons, it's actually requiring not protons, photons. So they did this experiment, and the method and how they were looking at the experiment, this it acted differently. Photons, I thought of it lost my word, photons. So in photons, if they were looking at it a certain way, it was behaving as a particle. And at another time, the same observer, so that it was an influence of the observer. And then another time, it was behaving as waves. So it had a duality, particle versus waves. But a photon doesn't have a mass. So they were doing observations. It was electrons as well. And then for some, they were shooting electrons, photons, so it was behaving as particles. And the observer did something else, but it was just the way how looking at it, and it started behaving as waves. So from particle to wave, and there was an influence on the observer on this experiment. So we influence the experiments we do by just
I have a
looking.
question on that. Is it the observer influencing the experiment, or is it just the way he's looking at it?
But he was looking at the same thing, but it was how the observer looked at it changed the behavior of the particle.
So it must be like a filter within us.
Yeah, but then we get into real philosophical discussion where we are everything is connected, whether we are influencing how particles are behaving. I'm not yet want to go there.
Yeah. So we had a question in the back. Go ahead.
You mentioned earlier that when black holes start burning to an infinitely small dimension, they burst and release all the energy.
That's what Hawkins suggested. But they're destroying, so when you have sometimes black holes can come together, they don't go together like this. So they go boom. They start twirling and they start moving together. Finally, they merge to one big black hole.
Okay, when they merge and they release the energy, so
that's radiation. That's the Hawking's radiation, and so they're losing energy, and energy being mass, so they're losing mass. And if they are not fed more mass or light, they start shrinking. They become very tiny, highly energetic, and then Stephen Hawking suggested at the time when it's reached the Planck's length, you have a final burst when everything blows up. But then you have this issue with the paradox of that information is lost.
Could it be some sort of a new small or a big bang itself?
Yeah. But the Big Bang, so that you have sometimes supernovas and the whole thing, but it's not a Big Bang. This is just something happening in the huge universe. If I'm not mistaken, the universe is the width from what they know because it's expanding. It's 10 to the 90th, something like that. But this is huge. I mean, you can't.
Sorry.
I'm sorry. About the black hole being upon the death of the black hole that massive radiation is. Was this a theory or was it recently observed? Because I heard something that was recently observed also.
Yeah, but actually measuring it was observed. So there was always a discussion: do black holes really exist? Because there is no light coming. So we only observed black holes by the fact there was no light, and light was gone. But now with this twirling of two black holes moving closer to each other, they measured this gravitational wave related to these two very heavy objects twirling.
That's what was discovered.
Yes,
not
exactly.
the death of a black hole.
Not the death of a black hole. No, the fact that really black holes existed through the fact that they measured the first time the gravitational wave carried by gravitons, which we still need to do. I mean, I don't do it, but I'm very happy.
I have
some friends.
Can we in any way relate ether to the gravitational waves, since ether represents the emptiness, and through observing.
That's a good question. That's a good question.
We make the material of emptiness in space.
Yeah, indeed. So you need some media for things to carry, and so the gravitational waves. It's just have a look at. They have also a nice cartoon explaining how these gravitational waves move through space.
So they are moving through ether.
Yeah, they're now, but I don't know exact details, but they have been revisiting with the idea. Before they said ether doesn't exist. Now they have to come back to this statement that ether doesn't exist, and there are some experimental evidence that perhaps there is an ether. Okay. But these are all still hypothetical questions. It's still a lot of research that needs to be done, but I mean, it gives also new openings to look at these things.
You explained that we are everything is one solid for energy. And how far do you think that? How long do you think we will remain? Do you think everything is made of energy, all in all?
It's the equation. It's the equation of Einstein. The equation is that energy is matter and matter is energy. But matter is really a condensed form of a huge amount of energy. Huge amount of energy.
I had the impression that what we perceive as particles or protons or neutrons is just vibrating strings, the vibrations of particles.
Yeah.
So are they like similar to those of photons but lower, smaller scale?
Photons, we have two types of very tiny particles. So you have strings, but then you have certain strings which are the bosons, which are carrying the force, and you have the fermions, which are basically the matter.
So that explains the mass energy field.
Yeah.
Photons have energy.
Photons are energy. Yeah. And everything, so mass condensed.
That's totally new for me.
Well, then, but yeah, you have to thank Einstein for this. So that mass and then people say, yeah, Einstein's law, E equals mc to the square. But if you look at it,
it's the vibration, that string and the vibrating things that create
the type how they vibrate, frequency gives rise to different matters.
The combinations that we perceive and different.
Yeah. And it can go already a little bit on a macro level, as I mentioned, the table of Mendeleev. So these are things you can measure. So you have neutrons, you have protons, and you have electrons. So these are like the building blocks. And how you play with the building blocks, you get this whole range of different elements from table of Mendeleev.
Sorry, Doctor. I know this is not exactly the subject you're speaking, but you're the most credible source to ask. I'm a little bit lost on.
I don't know, but I'm one of the. I don't play into.
I'm a little bit lost on dark matter and antimatter. If you could please explain it, and also where do you see them fit on the philosophical map?
Well, the dark and the dark matter is matter you don't see. So there is dark matter is matter you don't see, and in order to have all the mass and all energy in the universe, physicists calculated that there must be something else, dark matter, to make up the complete balance of what we have. We also have antimatter. So you have some place where you have antimatter. So you have one particle, you have a proton, for instance, in a nucleus, and you have an anti. And basically, when they join and meet, you have nothing anymore. And some energy. Yeah.
About the big bounce.
The big bounce.
Yeah.
Unfortunately, we're not there yet.
Yeah. Could it be that the universe started up as Big Bang, but where they split into matter and antimatter, and that's how like the antimatter universe and the matter universe, they both have gravitational.
And then we're back to this multiverse concept, because there are some theorists, and it's actually more philosophy, where state we have one brain, and then you have another brain, and another, and they hit, causing a big bang, and a lot of energy and matter is moved into the other brain in the other dimension. But this is getting very. You have theoretical methods to do that, but it's getting more into philosophy than something else.
Before we wrap up, sorry, I want to this fascinates me. So we have the basic atom, where we have protons in the nucleus.
Yeah.
Right. So and then you have, so all conventional wisdom would say that we have all these positives are pulling apart, and then you have these negatives that are surrounding them, who are pulling them to them, and yet somehow the nucleus stays the same.
But that's the blue ones.
Yes, I understand.
Okay.
So, but I've read that, in fact, all of this empty space that we're talking about isn't actually empty space. In fact, it's force that is greater than the pull apart from the in the nucleus. So in fact, space isn't empty. It actually has force that's greater than in keeping the nucleus intact.
Yeah, and that's a strong nuclear force. Yeah. And that's the quarks together with the gluons forming hadrons, being very, very strong. Being very, very strong. Because if you could release that, then you completely could convert matter into energy. And then you can, at home, do a nice calculation. So E equals mass and speed of light. Fill in your own body weight. Do the calculation, and you can see how much energy you represent. If you could completely burst open all and then convert everything to energy.
The other thing is, if we can go to the Einstein slide.
This one?
Yeah. So we talked about this E equals mc squared, and just to bring a little bit more of a, I suppose, a little bit more of a philosophical twist to it. So we're saying that matter and energy are the same, except the c squared, which let's call it vibration, is which is congruent to the Hermetic philosophy, where everything is determined by vibration. So basic energy and matter are the same. It's just that based on the vibration of that particular object, it's expressed in a chair, a cup, an apple, or a planet,
or the constituents.
Or the constituents, right. So just if we can, why was it when Einstein described this theory of relativity, he based the speed of light as a constant, and squared it.
But now with M2E, it's not always constant. Yeah. So there are possibilities that speed of light is not constant anymore.
And actually, since it can bend, it also is susceptible to gravity.
Yes.
Which makes it mass, which means
which is a particle being attracted where there can be a pull, and this is why light is being absorbed, and black holes are bending time-space and attracting light and trapping it. And at that level where there's no return, that's called the event horizon. So then it sucks everything, and there's no escape.
One last question, if there is any.
Where does the Hadron Collider, big thing that where does it?
Actually, based on the M theory, so now, as I mentioned, they're designing experiments, setting up hypotheses to do experiments to see, try little bits and pieces to prove. The Higgs boson has been identified, which was great news. This is actually explaining why something has mass, the Higgs boson. And now also other experiments which we are, not we, but the scientists are doing, is for instance, now everybody is very keen on looking at gravitons. We know that there are gravitational waves, and the quanta for gravitational waves is the graviton. If we can observe indirect or direct or indirect graviton, or a loss of a graviton, this, first of all, we have proved that there is a graviton. Secondly, if it moves out, it means that it moves into another dimension, so we have proved there are other dimensions. That would be neat. Then I mean, we're not there. So, but that's all the experiments. That's looking at the microcosmos, trying to also explain the micro with the macro.
Hey, trying to, was there anything else? No? Hey, she hasn't said anything. Go ahead.
Going back to the experiment of the observing the photons.
The electrons as well was
yes. I would like to know your interpretation of that. Is it that the photons have a certain type of consciousness, or is it that the observer affected the photons?
You really want me? That's my personal assumption, which I'm not going to carve in granite stone. So it could be that
mind, that is energy, that we have some influence on how these tiny particles perhaps behave. That's already a very bold statement. But this doesn't mean that I believe in telekinetics. I can't move that cup from here to there. If I could do, I can make immediately $2-3 million because there's still a bet out there stating that if on the scientific conditions you can prove you can do telekinetics, immediately they pay you $3 million US. And the bet is still open and the money is still there for many years. So nobody has yet moved that cup, but
Is the intention of the observer to move the particles in that way?
yeah, but influencing a photon or an electron is a different thing than moving this cup. I need, I don't know, a lot of energy to do so. So at that level, perhaps that can be an influence. At this here, well, at least if somebody in the audience could do that. But there, but on that level, on this tiny level, there perhaps could be some link there. But that's my modest, and I'm very skeptical still about this way of thinking.
Okay, I think you can we're still around for a little bit. You can have a bit of a conversation a bit later. But I want to thank Professor Sass for taking the time and sharing. Sorry. So I want to thank Professor Sass for coming and giving us his time and making this wonderful presentation. I think we had a very nice and interactive session. I certainly learned a lot, and I'm sure everyone else did. So thank you very much, and please let's.
They've been in the US, huh? Yeah, I know Hermes. So there's some training working.
Training?
3 million.
I know. It's a nice amount of money.
Sorry, for any